Hello, everyone. Good morning, good afternoon, good evening. Very happy to have you in this webinar today. Today we'll be talking about how to accelerate application delivery and operations in Kubernetes environments. So today we'll do a mix of slides and demos. It will be in 3 parts to kind of show how we can accelerate that path to the adoption of Kubernetes through accelerated development and also operation of these clusters. So part 1 is going to be how we can migrate existing legacy applications into Kubernetes. The second part will be about then reducing the operational overhead for these Kubernetes clusters. Okay, so we have migrated the application into Kubernetes, but then we also need to manage these Kubernetes clusters. So how we can reduce that operational overhead. And then finally, in the part 3, we'll be looking at how we can then also accelerate through the concept of ZeroOps, the modern application deployment into Kubernetes. Before that, let me just share my resume. So I'm Daniel Virassamy. I'm a principal cloud solutions architect in Mirantis. I've been working for Mirantis for a couple of years now, and I've been passionate about open source across my career, worked in Linux, worked in OpenStack, and now Kubernetes, and I'm looking at all the cloud technologies and definitely an open source advocate. So I started by mentioning ZeroOps here, and I think it is important that I do spend some time on explaining what we mean, we Mirantis as ZeroOps. Actually, the concept is quite simple, and we have that very simple line that explains ZeroOps by saying you do the apps, and we Mirantis will be doing the ops, right? And this is basically ZeroOps. And what we mean by this is, if you look at how you are today consuming public clouds, you don't operate the cloud, right? It's AWS operating the cloud. It's Azure, it's GCP managing the different components of the cloud. You're just consuming the resources and doing your apps and deploying your apps, right? What if you can have that same experience for your on-prem private clouds? What if, for example, you could have that same experience with Kubernetes running on VMware, or Kubernetes running on OpenStack, or Kubernetes running on bare metal servers, right? So this is what we Mirantis we do. We provide that ZeroOps offering around managing these different clusters, these different environments, so that you can concentrate on building applications and innovation and accelerating your go-to-market. Right. So across this webinar, we'll be actually talking quite extensively around the concept of ZeroOps, because this is very key in the adoption, whether we are going to look at that in the operational side of handling Kubernetes clusters, but also in the application side and how we can deploy applications more rapidly with that ZeroOps concept. Right. So it's going to be part 2 and part 3. Okay, so let's look at part 1, and part 1 is, as I said, what we can do with our legacy applications. So a lot of companies today have quite a large portfolio of applications that are running in virtual machines or in bare metal servers. And what if we can containerize these applications and move them to Kubernetes, right? Here, we typically talk about different concepts and different ways, actually, of migrating these applications, and we typically apply then the 4 R's. Do we need to rehost these applications? Do we need to replatform these applications? Do we need to refactor these applications? Or do we need to retain or retire these applications, right? So these are the 5 typical R's that would kind of apply to decide what to do with these applications. Definitely, if you decide to retain or retire these applications for various reasons, we are not going to talk about any application migration or modernization, right? But if you decide to rehost, replatform, or refactor your application, then this is where you will be starting to look at various strategies of doing that. Many companies try to adopt Kubernetes at scale by starting with the refactoring, but we are seeing a different trend of many companies saying, okay, we have that application portfolio. They are running today in VMs and or bare metal servers, and we want to push them as quickly as possible into Kubernetes. You may think that it doesn't really make any sense, in the sense that these applications are normally monolithic and you don't get the benefit of microservices and all. But one of the major advantages of moving these applications into Kubernetes is that you are using Kubernetes as a cloud operating system. So you avoid being locked into a given technology. So let's say, for example, you have deployed your applications in EC2. It's quite hard to move them to Azure virtual machines, right? For example, because you need to kind of transform EC2 instances and then re-import the image into Azure, for example. So it is quite hard to do. It's not a one-to-one mapping between a given virtualized environment and another virtualized environment. You need to do some work into migrating these applications, the data, the way that it's handling network, the way that it's handling storage. But if you do that in Kubernetes, the transition is a little bit easier, because Kubernetes is that cloud operating system that can operate and work across all these different environments. You can deploy Kubernetes on top of Mirantis Kubernetes engine. You can deploy Kubernetes on top of VMware. You can deploy Kubernetes on top of OpenStack, on top of AWS, on top of Azure, and then you can just move your applications around depending on various conditions, like pricing, for example. Right? If you believe that, or you see that you're paying way too much on a given public cloud, you can then move around these applications. Right. So this is where we'll start to look at replatform and rehosting these applications. The way that Mirantis addresses this topic is through a platform which we call AMMP. So AMMP stands for Application Migration and Modernization Platform. And how it works, it basically works into 3 steps. 3 big steps, and then I'll explain in more details how these steps, we can break down these steps. But the first phase is definitely we need to discover these applications, right? We need to build that application portfolio, and that tool allows you to kind of scan all your resources and build that application portfolio. Then once you have that application portfolio, you need to make decisions, and then you need to transform, and then you need to deploy these applications, right? And then you have that ability and choice of deploying these applications across various environments. Can be vanilla Kubernetes, can be Mirantis Kubernetes engine, can be any public cloud, OpenShift, Tanzu, right? You have that choice of running it on any Kubernetes clusters, on any infrastructure, right? So that's very, very important. We Mirantis, we are agnostic of the underlying platform. We will be helping transitioning from legacy VMs or bare metal servers into Kubernetes containers, right? So now let's look into a little bit more details of how we can do that with the application migration workflow. As I said, the first part is assessing. We need to assess the different resources, virtual machines and physical servers sitting in a given data center. So for that, we run workload analysis with something which is called X-ray, right? So we scan all these different machines, and then we apply something which is called X-ray. It's not X-ray from AWS, it's something which is specific to the product. And once we have discovered the applications, analyzed these applications, we create reports, and within these reports, we provide intelligent recommendations. So these recommendations are based on 12-factor development, right? And out of these, we would say, we would recommend whether some applications need to be retired, need to be retained, because of complexity of the deployment and the value that we observe on these applications, and the weight that we can put on these applications. And then some others, we would say, okay, it's worth investing in refactoring, or it's worth investing in rehosting or replatform, right? So that these recommendations are built into reports, and these reports are either technical or C-level. So that's also an advantage of the tool. So you can have two types of dashboards, one that will be used by the technical team and one that will be used by the C-level team to make the right decisions on how to move forward, right? And as from there, there is the notion of rationalization. And this is where we will be deciding whether we would reinvest or whether we would retain or retire these workloads, right? So if we are to refactor, then we will not be doing that through that tool. The refactoring goes through another type of service that we Mirantis provide to help the development team to rebuild the applications into microservices. But if we are looking at rehosting or replatforming these applications, then we will continue the work on that given workflow. Okay. So what do we do then? Is the first step is we transform. So basically here we retrieve all the different binaries from the running server, virtual machine or physical server. We retrieve all the binaries, dependencies, configuration files, startup files, shutdown files, any files that are related to your application. We retrieve these files. We build the Docker file, and as from there, we build the image. We push that image towards a repository, and we start to configure some of the artifacts to run that image into Kubernetes, right? So that's step one, which we call the transformation step. Then what we will be doing is we will write the blueprint. And what is a blueprint? A blueprint is the definition of how we want to handle the images, right? Or how we want to also handle the way that we are deploying these images. So it's a standardized way of describing which image we'll be using, amount of resources we'll be using, the number of replicas, etc., etc. So here we start to define all the different artifacts that will be needed to deploy it in a Kubernetes cluster. And once this is done within the blueprint, we can use that blueprint and deploy that into a target Kubernetes cluster. Again, whether it is Mirantis Kubernetes Engine, whether it is OpenShift, whether it is any of the public cloud Kubernetes clusters, right? Obviously, we have that in a iterative mode. We put that in an iterative mode so that the first deployment, if that does not work well, then we have that ability to come back to the first step. If needed, rebuild the image. If needed, redefine the blueprint or update the blueprint and then redeploy, right? So we reiterate multiple times until these images are running properly with the proper state. So that's in a nutshell how the whole process works, right? We want to explain a little bit what are the compatibility portfolio. So in terms of operating system, we support all the major Linux distribution, whether it is Red Hat, CentOS, Ubuntu, Debian, right? So we support all these different Linux distributions, Rocky Linux. We also support all the major Windows distribution, including 2022, which is not in that list, but we do support 2022, and also AIX distribution, right? So this is on the operating system side. And then on the application side, we support the major runtimes. So if you look at the Java middleware, for example, you can see all the major middleware here, WebSphere, WebLogic, GBoss, Tomcat, Wildfly, right? So it's all supported by application modernization across these different distributions. When it comes to Windows Stack, obviously this is related to Windows. So IIS Server, applications, .NET, Java, .NET Core, it's all supported by the application, right? And when it comes to other stack, so Golang, Node.js, Nginx applications, Golang applications, so all of this is also supported. And if required, and if you do have some applications that you don't see in that list, we can double check and whether we support it. And if not, then we can work on something. For the database, typically, what we'll be doing is we would not handle that through the application modernization. as it holds sensitive data, and we would prefer then to do that through some services engagement, right? So then we can also tackle the MongoDB, MySQL, Postgre, Cassandra migration from a given environment to another environment, and then through application modernization platform, we would be reattaching the moved applications, the migrated applications, towards the new target database. Okay. One important thing is we don't need the source code, and that's very, very key. We don't have any agent in the application, in the running servers, whether it is virtual machines or, again, physical servers. We don't have any agents running in this, and we don't need to have access to your source code, right? So we just SSH into your machine, and then we scan that machine with the tool. We identify known tools. We can whitelist or blacklist some of the running binaries, and then we provide that report, right? The assessment also, in terms of mapping, we can define whether an application is stateful, whether an application is stateless, whether it is a standalone application, whether it is a clustered application, how hard or easy it is to migrate applications. And this is also very important, right? Because we can define based on this simple matrix, and that microservices, Selenium type applications, PHP applications are quite easy to migrate, while all the database applications, message queues, CMS clusters, and all that are a little bit harder to migrate, right? And what we would typically recommend is to start with the easy applications first. And the reason we say that, to start with the easy applications first, is because it allows you to get your hand dirty with these easy applications, right? So you understand the concept of migrating these applications, of building the artifacts with a tool, of building the blueprints with a tool, right? You get your hands dirty, but with these easy applications. And then as you get more and more experience with these applications, then you can move towards the medium easy, medium, and at the end, the hard applications, right? So that's the general concept. Obviously, there are some exceptions, but that's the general concept. Okay. So this is an example of a detailed report and recommendation. Here you can see from that report that we have one Nginx application, 2 Java applications, and 1 MongoDB and 1 Tomcat application. You have the list of all the technological stack, which is Java, the processor's dependencies, the starting file, right, which is also related to Tomcat. All the different networking configuration, the working directory, right? And then we also then give, based on what we have identified, whether the effort will be high or low in terms of migrating, right? So what the process user is using, so it's root, right? So therefore, the level here, we know that we would need to, we'll need to make some adaptation so that we cover that recommendation of not running that process as root anymore, right? So we'll need to check a couple of things, but that's the general recommendation, right? So we give that based on these criteria that we have identified, whether it is easy or not, and then we give some explanations here. Another view of that detailed report, here we can see an application map, and then on this side you can see again the same type of reports, right? How does that work at scale then? So how does that work at scale? Here you can see that we have the notion of wave. And what is a wave? A wave is a set of resources, virtual machines or physical servers, right? And we group these physical machines or virtual machines into these waves with various logic. It can be business logic, it can be product logic, right? So you can define it as you want based on how you are managing your application portfolio, your different verticals, and also how your governance works. So in that case, you can see that we are defining various wave sets with internal owner group, right? And within these wave sets, we have various waves. And what we can then do is we can schedule migrations within these waves, right? So that we can start with A first, done, with B, done, etc., right? So this is the approach of doing it at scale by defining these different waves and wave sets, and then scheduling these migrations in a controlled manner. So how does that actually works then in reality? And this is an example, a real example of a project that we realized in 2022. There were around 700 applications to be assessed, right? In the past, if we had to do that manually, each application would take us around 1 week to assess, right? So you can then count the amount of for 700 applications, the amount of weeks and months that would have taken us to do the full assessment. Here you can see that within 3 months, we did the 700 application assessment, right? So that's very, very key. Then in parallel, we started to containerize, right? So month 3 and month 4, we started to containerize. As from month 5, we started the Kubernetes deployment, right? And that went out until month 12, simply because we deployed multiple Kubernetes clusters, and we also configured various components within these Kubernetes clusters, right? So that's why then, as from month 5, we have in parallel also the deployment of these applications within these Kubernetes clusters. So this is done in parallel here, and then we continue a little bit till month 12, right? So it took us around 3 months to assess and around 10 months to deploy these applications into a modern platform based on Kubernetes, right? So 600% faster to modernize. If we were to do it manually, we would have taken ages to do that. But with automation, we have been able to do that in around the whole project, 12 months, right? It's 200,000 plus human hours saved. And in terms of timing, again, it's 10 to 12 months of modern applications versus 30 months plus if we were to do it manually, right? So that's the type of KPIs that we are able to achieve with that platform. All right. So before I move to this section, part 2, we're on time. Let me show you a little bit how the platform works, right? So this is the platform. In the platform, as I explained, we have various steps, and the first step is discover. And here you see that I have defined a wave for myself, which is my name, Daniel Virassamy, right? So I'm going to click on that wave, and I already have a machine. I already have a EC2 virtual machine, which is running and which is connected. So you can see here the available. It is I can connect to that machine through SSH, right? Because if I add a host, the only thing that will be required for me is to define the operating system, whether it is Linux, Windows, or AIX, to give the IP address or CNAME for that given machine, the type of connection here, SSH, give it a credential, the username and IP address, and then the port on which SSH is listening, right? Once this is done, then I can connect to that machine. There are some prerequisites that are checked, like, for example, do I have sudo rights on that machine? Because I need to have these sudo rights to go and check these different files and folders. And then once this is done, I discover, right? So I would click on discover here, and that will go and discover the various services into of my application. So I already run that, so it can run in parallel. And here, in terms of components that have been discovered, you can see that there are 3 applications that have been discovered. I have Tomcat applications, and I have an Apache 2 application and MySQL. And actually, why these 3 applications have been discovered? I have these Tomcat applications running here, my app and sample hello world, right, GSP page. So these are the sample Tomcat applications running on that machine. But I also have a WordPress CMS. So that's why it's also discovering Apache and MySQL, right? Once this is done, then I can X-ray that process to better understand what it contains. And once that X-ray is done, then I will get a link here to containerize that image, right? To transform that image, which will transform that application. Before I start that transformation step, let's look at the type of reports that I can build. So here I'm going to generate a technical report. It's going to be very simple because I only have one host, right? So that's why you see one host, but you can imagine that with a wave with tens or hundreds of machines, you will have a more complete graph with all these different hosts, whether it is Linux, Windows, or AIX. Then you have recommendation, whether you need to reinvest or you need to retire that host. And here you see that it's recommending to reinvest in terms of rehost these applications, right? And not retain or retire these. So it's based on the complexity of these applications. And for the reinvest, then that host will have, again, I have only one host, right? So that's why the graph is very, very simple. But I have two applications, one which is Tomcat applications and one which is WordPress CMS. And you can see here whether the complexity is high or whether the complexity is medium. So medium is for Tomcat actually, and high is for the WordPress CMS, right? I have some more details about these applications, one Java, one MySQL, one Tomcat. I have the graph here that shows the different identified applications. And then here I can check, right? So if this is a Tomcat application, I have all the details that I already showed during the presentation with dependencies, technology stack, the files that needs to be copied, et cetera, and the complexity of kind of migrating this application, right? And at the end, the result, whether it is medium or not. And if I check with a WordPress application, here I have two items, Apache and MySQL. So here again, I can select, and you can see that for the CMS Apache part, it is a little bit higher in terms of migration. And again, I have all the details. And for MySQL, it's the same, medium migration, and again various details, right, of what needs to be deployed. So that's the report that I can build in terms of practitioner report. And then if I look at the CIO report, it's going to be a little bit simpler, right? Again, I have only one host, so it's not it's going to be very, very simple. If I had more hosts and applications, then it would be a little bit more complex, I would say. But you also see the modernization priority, right, by subscriber, right? So this is also very, very key. Which one you need to migrate first, basically, right? We again provide some recommendation in terms of priority. So okay, we saw the discovery, we saw the report. Now let's look at the transformation. So transformation basically is, as I said and explained, is the packaging of that application, which is running in a virtual machine, right? Live virtual machine. How we can package that into a Docker container. So for that, I'm going to check the components. They are all ready to be containerized. Let me containerize that Tomcat application because of amount of time that I have. You can see that automatically it has generated the Docker file, right, with various details. And these details come from what has been analyzed, right? What files need to be copied, with the base operating system that needs to be pulled. The source code that needs to be packaged, the starting Tomcat script, etc., right? So you have these various details. You have some select files here that you can include or exclude, right? You can decide then, okay, I don't want to import that file, or I don't want to export that file, right? That's not, or include that file, sorry. That's not what the target environment do not need these files, so we can discard these. So you still have that control here. And then you can have the control also in terms of container config for what would be needed for the running Kubernetes cluster. Okay, so I'm not going to do all that here. I'm just going to build that image. So to build that image, I need a build box. So a Linux box here which runs Docker, into which I'm going to call Docker build. Then I need a registry where I'm going to store this image. So I prepared a registry on Docker Hub, right, which is called camudv /webfront here, right? So I'm going to do that in Docker, but I can also use Mirantis Secure Registry, right? So Mirantis Secure Registry is a private registry which is on the same technology as Docker Hub. I'm going to give it a name. So as I explained, it's camudv webfront. Let's look at this here. And then the tag, let's put .0. Okay, because I already have 1.0 there. Let's remove the local file after it's built, and then I just click on build, and then it's going to build that image, right? So you can see the logs here. It's going to access the remote repository, check the disk space, enough space, good, and then it starts to prepare the packaging, and then build the Docker image and push that Docker image, right? So at some point, I'm not going to only have 1.0 tag here, but I'm also going to have 2.0 tags, right? Okay, while it's doing that, what I'm also going to do then is, again, just because of time, I'm going to show you how we can then use that image. Okay, so here I've created a blueprint, and to create a blueprint, it's pretty simple. You click on create blueprint, you give it a name, namespace in which you want to deploy that application, and then a description of that blueprint, right? So I can build something like, for example, Tomcat, give it a name, Tomcat, and then apps, for example, right? And then I create that blueprint. And once I have created that blueprint, this is where I can manipulate all these Kubernetes components. So the deployment components, the config map components, the secrets that I need to handle, the ingress that I need to handle here. I have that error message because I haven't defined any deployment yet, and then some of the preferences, right? So to create a deployment, it's pretty easy. I create a deployment here, call it Tomcat. And then once this is done, I can add my containers here, right? And this is where I'll be adding the container name that I want to use, the image name, the URL, so the remote URL, remote repository, the tag that I want to use, the base operating system, and then the ports on which it will be listening, right? So again, for the sake of time, I've already did that for Webfront. This is the version that I'm using. This is the deployment that I have defined, right? So I have a Tomcat application with 1.0 tag. So this is that image actually, and it will listen on 8080, right? So I define all these applications, and once this is done, then I can basically create a workload. So create or deploy that application, right? So I've created the blueprint, and I'm going to deploy that application. So I select the environment or the type of environment. I can indicate that it is 1.0, for example, workload name. I'm going to select the running Kubernetes cluster. So here I have a Mirantis Kubernetes engine that runs in AWS. I want to, I can override namespaces, but here I'm going to put it in Webfront namespace. And then the ingress, which is deployed on that Kubernetes engine, which has already been discovered by the tool, is Nginx, right? So this is done here, and then I just need to validate that. Select the node on which I want to deploy that application. So I can select the first node, for example, in that case. And then I start the deployment, right? So the deployment has started. If I check my cluster, so here you will recognize Lens. So for those who do not know Lens is one of the major, if not the major UI and IDE that is used to manipulate and access and control various resources within Kubernetes clusters. And you can do that at scale with the capability to connect multiple clusters, whether it is Mirantis Kubernetes Engine, whether it is Tanzu, whether it is EKS, whether it is AKS. You can have all this within one single pane of glass and access all these and manipulate again all these different objects You also have a local development cluster that allows you to build your code locally, test it locally before pushing it elsewhere. And then you also have that ability of sharing and working collaboratively with your peers through the Mirantis, through the Lens spaces, right? Lens also offers the capability to extend. So you have extensions that you can build based on the Electron and Node framework, so that you can add your own capabilities and features within Lens. And finally, you also have the security center, which gives you the full visibility of the security posture in terms of images, in terms of cluster configuration, in terms of policies, etc., right? So here I'm using Lens. The target environment that I used in AMMP application modernization and migration platform was MKE on AWS. So this is the cluster, MKE MSR, right? And you can see that Webfront is running for less than 2 minutes, right? So this is the application that I just deployed, right? I just need to do a very simple thing here. I just need to apply that services, because I didn't define the services object in the AMMP, but I could have done that in AMMP also, right? But here I'm just running that services file, and actually that services file is very, very simple. I'm just doing a node port here again for simplicity to expose that service, right? So let me apply this. The file is applied, right? So now I have a service that exposes that pod. And that's also one of the very powerful thing about Lens, is that I can very rapidly define on which pod it runs, right? So click on the pod node. I know that it's running on that node. I click on the node. I just need to find its CNAME. So that's the name here. And now I can simply go back. I know it's 35, 7, and then my apps like this. It is, right? So that application here that has been running in a VM, Hello World, with my app on 8080. So that's the VM application, is now running in Kubernetes, right? That node of Kubernetes on that port, which is the node port with my app, right? And I do have another application, which is this one, the sample, right? So I just need to change this one, put it sample. I'm also going to have that application, right? So it migrated all the Tomcat applications into that container, okay? So basically that's how it works, and that's how you would be accelerating the migration of your applications from your legacy platforms into Kubernetes. But now that you have your Kubernetes clusters running, right, and you can have multiple Kubernetes clusters running, whether you want to do namespace as a service, whether you want to do Kubernetes clusters as a service, right? Both policies applies, and actually you can have a mix of both. You then need to, and you can have multiple clusters then that runs. And if you're in a hybrid environment also, you will have some of these running in AWS, some of these running in Azure, some of these running on-prem, on OpenStack, or on bare metal, or on VMware, right? So you have these different clusters to manipulate. So it is then, that scale and complexity of handling all these environments is also one of the blockers of Kubernetes adoption. And to remove that blocker, this is where you also need to have a way of easily handling these clusters. So this is what we call in Mirantis Lens Autopilot, right? Again, Lens Autopilot is a ZeroOps platform in terms of how we handle these Kubernetes clusters. We remind again that very simple word or phrase, sorry, you do the apps and we do the ops, okay? And this is true at scale, where you have multiple clusters running on-prem, in the clouds, various configurations, various sizes, various components deployed in it, various requirements for teams and applications, right? So you have that heterogeneous environment, and you need to have the proper support on these environments. And this is where ZeroOps platform, Lens Autopilot as a ZeroOps platform comes in, where we bring the power of Lens with the power of our DevOps engineers, okay? So it is a combination of Lens and our DevOps engineers. So how does that work? Again, we give you that choice. You select the environment where you want to run. Is it do-it-yourself? Is it Mirantis Kubernetes Engine? Is it EKS, AKS, GKE, OpenShift, Tanzu? Right? You have the choice. Again, we are agnostic of the platform, very similar to AMMP, where we were agnostic of the target environment. Here we are agnostic of the platform. You have the choice of selecting your proper operating system. Today we support Linux for that platform, where you can have the choice of using Rocky, Red Hat, CentOS, Ubuntu, SUSE, for example, right? So you have that capability to choose your operating system. And then obviously the Kubernetes cluster that runs on top of that. Okay. Again, and Mirantis Kubernetes Engine, do it yourself, Azure, EKS, etc., etc. Once you have that choice, you want to be able to deploy the different services that will support your applications in a consistent manner. So Lens Autopilot is a SaaS offering that leverages GitOps, right, to deploy these different components in a consistent manner across all your different clusters. So we address these big topics like CI/CD, for example. We can connect to GitLab. We can leverage GitHub Actions. We can deploy Argo CD or Flux CD within the cluster. We can deploy GitLab within the cluster. So this is what we will be supporting in terms of CI/CD, right? Logging, monitoring, and alerting, we will be supporting the standard Elk stack and Grafana stack, right, to manage logs and metrics. We also support Loki if you do not want to use Elk stack but want to manage all the logs within Loki. We also use Loki. We have Goldilocks for all the recommendations of resources and how much resources we need to apply on each of the running applications. And we also have KubeSpy to help manage the different resources, right? In terms of networking, we support the standard ingress, Nginx ingress component. We also have Calico as the default CNI, and then Istio as the service mesh component. Okay. For security, we have Falco to manage the events, Crane to manage our back or to have the proper visibility on our back, and then Aqua Security Suite to have the security posture on the infrastructure, so operating system, for example, on the Kubernetes components itself, and then all the different Kubernetes objects, whether it is pods, whether it is network policies, etc., etc. So we use the Aqua Security Suite, and then we can also leverage OPA and Keycloak if for the identity management. And then we have the ability to have to integrate other-party applications, third-party applications through these add-ons with Sysdig, for example, if we need a enterprise-grade Falco support, Trilio if we also need backup and recovery for our clusters, Tetrate if we need a enterprise-grade support and extra features for Istio, and then Datadog if we need to leverage another telemetry system, right? So all of this is out of the box and can be enabled again through that SaaS offering and using GitOps. How does that work? We have that single source of truth that runs in Git. Our DevOps engineers manage these different components. So make sure that they are up to date, make sure that they are properly configured, make sure that the resources allocated are properly configured, make sure that the security and CVEs are properly managed, right? And then we, again, the important topic here is how we can deploy these different components in a consistent manner. And for that, we have a concept of layers. So we have a common layer where we can have all the common components and all the common configurations in this common layer. And then we have a per cluster customization. So we can say, for example, I want to treat my staging differently to my production. So I want to have a little bit more flexibility on my staging compared to my production, right? So I can then have a common layer which will be applied to both components. And then I have a per cluster configuration for my production where I need to have enhanced security, for example, right? So I have this approach of common layer and then per cluster customization. But the idea here again is to have it in a consistent manner. So how does that work? So basically here you can see that I have two clusters. These are two AMMP clusters again, but this time they are running on OpenStack, right? So I have Mirantis Kubernetes Engine number 1 running in OpenStack, and I have Mirantis Kubernetes Engine number 2 running in OpenStack. So for this one, I've already deployed Lens Autopilot. So you can see the namespace here and all the applications that has been deployed, right? And so I deployed everything here. So that's why you can see Argo CD, Falco, Goldilocks, KubeSpy, KubeBench, Loki, Milio, right? So I've deployed all these different services. And if I do go on network and look at these different services, I can access these various. I don't have any ingress here. I can access these different services. Okay. Now let's see how I can deploy that in Autopilot number 2. Right. So to do that, it's quite simple. To do that, I need to very simply call FluxCD, right, and connect FluxCD to my remote repository. So let's say here I have FluxCD, bootstrap it. The owner is Lens DevOps Care. My branch, right, where I'm running the code for my given clusters. And here I'm not going to connect it to cluster number 1, but I'm going to connect it to cluster number 2, right? So this is where within that cluster number 2, where I'm going to actually define which applications I'm going to deploy, right? All right, so I connect it to Git, right? It's going to connect and download, clone the proper repositories and configure everything. So I can check these then in custom resource definition, where I will have all the FluxCD components that will be deployed, right? So they are just deployed here. I have FluxCD customization. I have FluxCD source toolkit, right? You can see that at some point it will show me that I'm connected to the proper repositories here, right? So in live, I've connected to GitHub, right, where I have my code. I can check the Helm repositories, right? It's still empty here, right? So now it's being populated on what are the different repos and where I'm putting these Helm charts. And I also can check the Helm releases, but here I haven't deployed anything, right? So here you can see that I've connected it to the remote repository. And very easily now I'm going to activate all these components. So to activate all these components, I just need to go to Stack, Apps, right? Apps. So here you can see that I have two clusters, cluster number 1, cluster number 2. So I'm going to go to cluster number 2. Right, and here I'm just going to activate the components that I want, right? So for simplicity here, we packaged or we grouped all these into these bigger groups like security, service mesh, LMA, CI/CD. But obviously we can refine all these and say, okay, I want only Grafana and Prometheus. I want only for the CI/CD piece only FluxCD. Right, so I can then define in more granular way with what elements I'm deploying, right? So I just going to add this file. So now the changes have been pushed towards the repository, and I just need now to wait for the apps to start to be reconciled, right? So I wait a little bit, and at some point, Flux will detect that there is a change in the repository, and then, okay, apps now is not ready, it's false, right? So it's starting to get reconciled. I can check here, the Helm charts will be populated, and the applications will start to be deployed in the Lens autopilot, right? So we can see here that yes, the applications are starting to be well. We need to wait a little bit because this is still the yeah. Here we can see that Kubench is being deployed. Right, so it's starting to be deployed automatically, right? So this is how we can, in a very standard manner, very standardized manner, also manage at scale these different clusters. We don't need to go into each of these clusters and configure manually this. We have that type of automation that needs to be built to accelerate the adoption of Kubernetes. Step one, we move legacy applications into Kubernetes to get the benefit of the cloud operating system, right? Kubernetes as being the cloud operating system, and move them around if required. And step two, we automate the ability to deploy all the components that will be supporting my application, right? So I need, for example, to scan my application, I need a Crane to check the RBAC posture. I need Goldilocks to check my applications and check whether the application is using properly the assigned resources, right? So this is typically all the assisting components that you will be deploying in your cluster, right? So now let's look at the last step, which is step 3, where we want to go a step further and look at how we will be treating modern applications. So all the applications that are not coming from legacy or from legacy, but you have refactored, and that are microservice or developed into microservices, or if that makes sense, and then also cloud native, right? Ready to be deployed in these modern platforms. So for this, again, we want to do ZeroOps, and this is also very, very key. How does that work? Here we are using a component which is Lagoon. So Lagoon is an open source project, right, in the space of application delivery. And we have packaged Lagoon, right, as that open source project that Amazy.io is the main contributor for, right? So Amazy is part of Mirantis. Amazy.io is part of Mirantis. And Amazy.io provides a product around Lagoon to offer that experience of ZeroOps for application delivery hub, right? So this is very, very key, because the concept here is you have your code, okay? You are developing your code, you are developing your web applications, for example. And these web applications, typically, you will need to do the similar things that I did with AMMP for legacy applications. You need to build an image, build all the artifacts around that image, right, to host it into Kubernetes, create Kubernetes clusters, deploy various components within that Kubernetes cluster, and then host your application inside that Kubernetes cluster, right? What Amazy does is you would only concentrate again on your code. So you do the apps, concentrate on the ops, on the code, and we do the rest. We do the ops, right? So we take your code through that Amazy.io platform, and we do all the rest. So I'm going to explain it here. It's a little bit better here, so you can see how it works, right? So you have your code, you push it in your repository, right? Standard way of handling code. Then you have a component which is Lagoon core, and it gets that information. You have a webhook, and that Lagoon core here has that information of that you have pushed a new version of your code, right? So what will happen is Lagoon core will tell respectively to all the Lagoon remote to start the deployment. So Lagoon remote then will start the deployment of that given code, right? So Lagoon remote tells Lagoon core about the deployment status, and Lagoon core then informs the developer about the status of the deployment. So it's a very simple process. You would be pushing the code, and then Lagoon will be doing all the rest. It will get that information. It will handle the cluster, right? So we have an offering of Lagoon where of Amazy.io, where we handle the cluster, we deploy the cluster, we handle the cluster, right? You don't even need to do that. It's all done by amazee.io. Then we push the package the code. We package the code. We push the code towards these remote clusters, and then we give back the information of whether it is operational or not, right? So that's a little bit more detailed view of what happens. You have, again, the same process. We push the code, right? And what happens here is that here we will be cloning the repo, analyze the code, build images, create the Kubernetes objects, do the rollout, monitor the rollout, and then run deployment tasks, right? So this is the build pod that will be doing that, and then give the status back to Lagoon code to say it's working or it's not working, right? So that's what we mean by doing ZeroOps for applications and for modern applications, right? So that's step 3. Okay. So what did we see today? But today what we have seen is, yes, there are various steps to be able to do to accelerate Kubernetes adoption and to accelerate your capability to deploy applications and to accelerate also your capability to operate these clusters. Step 1, handle your legacy portfolio and accelerate that migration into Kubernetes clusters without having to refactor all these applications, right? We will be scanning, we will be providing new recommendations. For the applications that needs to be refactored, we will provide this recommendation. For the applications that needs to be retired or retained, we will provide that recommendation. But for all the others, rehost or replatform, just to start getting the benefit of Kubernetes in terms of Kubernetes as being that cloud operating system where you are not locked into a given provider and you can move around your applications. So that's step 1. Then step 2 is you do need to have automation to build consistently your clusters, right? And this is where Mirantis helps with Mirantis Container Cloud and MKE, but also with Lens Autopilot that is based on the power of Lens and also the skills from Mirantis DevOps team. And finally, we saw how we can accelerate, again, with that concept of ZeroOps, how we can accelerate the application deployment of modern applications with Lagoon open source project and amazee.io by you having only to handle your code, pushing your code to Git, and then the amazee.io platform will grab your code, package your code, define all the proper artifacts, and then deploy that in a cluster that you don't need to manage, right? If you don't want to manage that cluster, amazee.io can manage that within the platform, right? What it allows you to do, you concentrate on your code, you do the apps, you build innovation, and we do the ops. You have a cloud or a public cloud-like experience, but with the security of being on-prem, with the sovereignty of being on-prem, and also with the ability to manage your cost, right? By being on-prem. You are not locked into a solution anymore because you have moved your applications. You have that capability that reversibility capability to move away from a given vendor because you are on Kubernetes and you control your cost, right? And open source is very key also here. All the different items that I showed you, Kubernetes, Lens Autopilot, and all the different components in Lens Autopilot and Lagoon, they are all open source, right? So you can leverage these open source projects and you are not locked into any proprietary systems. And then trust. We, Mirantis, we are a trusted partner that can provide offerings full stack on each of these steps. Step 1, the migration of your legacy applications. Step 2, the support of Kubernetes clusters at scale, right? Whether it is multiple Kubernetes clusters in different environments, but also small and large environments, small and large clusters, and also all the different components that you would need to build applications on top of these Kubernetes and do that in a ZeroOps manner. And then also in terms of applications, we have that portfolio of also helping you to deliver your applications more rapidly at scale with the right level of security, right? And this is what we call ZeroOps. So yes, do not hesitate to reach out to me. You can find me on LinkedIn if you have any questions. You will receive also from our marketing team everything that I shared today. Again, if you have any questions, do not hesitate, reach out. Thank you very much for your time today, and I wish you a good rest of your day. And looking forward for having a next webinar with you in the coming weeks and months. Thank you very much.